First, let's take a step back real quick. Way back. In the 1950s, research began on how to organize and store data in computers. The first data structure was the array, which is still widely used today. Through the decades, more sophisticated data structures were explored until we get to what we have today. You can find out more about the history of data structures at the link in the comments. In short, a data structure is a way to store and organize data so it can be accessed by other systems or code. Each type we're looking at today has a different strength. Understanding which to use when is the key to unlocking a successful interview and career. Lists in Python are like a to-do list, versatile and easy to modify. They can store a sequence of items which you can add, remove, or change as needed. Lists are ordered, which means the items will stay in the same sequence you created them, and they allow duplicates. This makes them perfect for scenarios where you need to keep things in a specific order. Let's take a look at some code. Remember, when working with lists, you can easily retrieve an item by its position. In coding, we start counting from 0, so the first item is accessed with 0. To add an item, use the append function. To remove one, use remove. Changing an item is as simple as specifying its position and assigning a new value. You will see here that lists are enclosed in square brackets. We have two different lists, fruits and fruit2. You can call or retrieve an item in a list by using the name of the list and square brackets with the numeric representation of the location in the list. Keeping in mind that in coding, you start with 0 as the first item. We're going to print the first item in the fruits list by using 0. Next, we're going to add a new item to our list. We do that with the append function, and then parentheses with the item we're adding enclosed in either apostrophes or quotes. The next line removed an item. To do this, we use the remove command and the name of the item to be removed. Finally, we're going to change an existing item. We do that by using the name of the list, the square brackets containing the placement of the item to be replaced. We will change the item in the second position, which is 1, and we will change it to blueberry. Now for a bonus, let's look at a more advanced scenario. Let's add items from one list to another. We will use a for loop in this case. For f in the fruit2 list, we will append that item that we have just iterated to. Finally, let's look at our resulting list after doing all of that by doing another for loop to loop through and print out each item on a separate line. You will see that we can also print the whole list on one line with the print command and the name of the list within parentheses. Let's take a quick look at the whole Python script and the result. All right, let's move on to dictionaries. Dictionaries are enclosed by curly brackets and have field names separated by colons and then the value or list of values. See what we did there? We're building on the previous section. So, a value in a dictionary can hold a list. You will notice that the dictionaries look similar in structure to some JSON data that you may have seen. So, you can add a new field to a dictionary easily with the name of the dictionary and then square brackets, the name of your field, and equals the value. However, you cannot add a new record or row to a dictionary. You would instead create a list of dictionaries by creating a new empty list like this, then using the append function we used a moment ago. Now, for another bonus, the .join function can be used to concatenate the list of courses so that we can print out the name of each student and then the list of their courses. Just like this. Let's look at the result. All right. Move on to sets. A set is an unordered collection of unique items. Use sets when you need to eliminate duplicates in a list or perform union operators like intersection, difference, or union. Again, sets are also mutable or able to be changed. Let's take a look. So a set is enclosed in curly brackets like a dictionary. however, only includes the items instead of the key item pairs. So you can add items with the add function, with the name of the set, .add, in the parentheses, the value you want to add to your set. To remove an item, you use the discard function, and then in the parentheses, you put the value you want to discard. Now, let's look at those union operators. The pipe will perform a union, which combines two sets, removing any duplicates, similar to the union concept in SQL. The ampersand will give you the result of what is the same in between the sets, commonly known as an intersection, while the minus sign will give you the difference between the two sets. In other words, all the values that don't match between the two different sets. Let's take a look at the results of this script. Alright, it's time to smell the tuples. Tuples are like a sealed time capsule. They're set in stone once created. You can't change them, but that's exactly what makes them useful for storing data that can never change, like coordinates or fixed settings. Just like a sealed tulip bulb, once planted, it's there to stay. As such, you cannot add, remove, or alter any items in an existing tuple. The only way to add items would be to create a new tuple object. So, like tulips, tuples are pretty but have a singular use. Let's take a quick look at the code. Here, you'll see that tuples are enclosed by normal parentheses. We can refer to an item in a tuple by using the name of the tuple, square brackets, and then the placement within the list. And we could even include a tuple as a key in a key value pair in a dictionary. I've been asked about data structures in my interviews, including how do you tell the difference between a list and a tuple? And when do you use each data structure? So hopefully, now you can tell the difference between a list and a tuple. If you can't, I'll put in the timestamps of the explanations of a list and a tuple here. Let's cover a few examples of when to use each data structure. You need an ordered collection of items that you might need to change later. Lists. You need a key value pair mapping for fast lookups. Dictionary. You need a collection of unique values and may need to identify the differences between those collections. Set. You need a collection of elements that will never change. Tuples or tulips. Now you know everything you need to ace that data structure part of the interview and have a great foundation of how to create and manipulate different data structures in Python. Got questions or need further clarification on any of these concepts? Drop them in the comments below and I'll be happy to help you out. If you found this helpful, be sure to like and subscribe. For other Python tutorials, be sure to click in the left-hand side. And for our SQL tutorials, click over here.